Let us first see what is that Bernoulli's theorem is. The Bernoulli's theorem says for a incompressible, non-viscous, streamlined fluid flow. I have discussed all these aspects in the other video. Please look into that if you still have doubts on that. The sum of potential energy, pressure energy, and kinetic energy per unit mass always remains constant. That means it's like a conservation of energy. If one energy increases, other energy decreases, but the total energy of the system always remains constant. Let us try to apply it to the wing of an aeroplane. Say, let us see. Let's imagine this is the shape of the wing of an aeroplane. It is designed like this. It was like this. Say, it's designed like this. When somebody designs the wing of an aeroplane like this, and the aeroplane is moving forward this way with a huge velocity, it influences the air around. But because of this curvature that it has, here air cuts with higher velocity. The fluid lines, the streamlines that I am drawing are closer, which indicates that there the velocity is more when compared with the lower part of the wing. So because of the shape, because of the design, in the upper part, velocity is more when compared with the lower part. As velocity is more, it is obvious that its kinetic energy is more when compared with the kinetic energy of the lower part. The theory says the sum of potential energy, pressure energy, and kinetic energy is constant. As it is approximately horizontal, potential energy is not a variable here, need not worry about it. We treat that as a constant. So, in these two, that is in this pressure energy and kinetic energy, if one energy increases, it's obvious that the other energy decreases. So here, as the kinetic energy has increased, the pressure energy decreases in the upper part of the wing, and in the lower part, as the kinetic energy has been decreased, pressure energy is more. So it's very clear when the wing is shaped this way for an aeroplane, the upper part will experience lesser pressure. So pressure try to push this upper part down, lesser value. But the lower part experience more pressure. That means there is more resultant pressure energy from the bottom. So it's very clear. It tells you simply that there is a more pressure acting from bottom to top when compared with pressure acting from top to bottom. Therefore, there is excess pressure energy from bottom to top. That will help what? Help uplift. That uplift is called aerodynamic uplift. That makes the takeoff easy. So particularly when the machine is taking off from the ground, it's very heavy. So it takes the support of aerodynamic design to make the journey little more comfortable for the engine. That's there in the machine. That's there in the aeroplane. That's how the aerodynamic lift works basing on Bernoulli's theorem. I can simply tell you another small example. We'll take just another small, simple example to tell you another small application of that. Let's assume it is a stormy day. We are in a outskirts of a city. We want to take a shelter. So we have no other place other than a small hut there. So we have gone into the hut and we have closed the doors. This is where you are. It's a very heavy stormy day. A lot of wind and air is coming. And to protect yourself, we have closed the doors of that small hut. So what happens now? Outer part experience a lot of air than the inner part because the door is closed. So it's obvious that what happens inside, outside is velocity is more, but inside velocity of that air is less. The same application. As the velocity is more, kinetic energy is more outside, kinetic energy is less inside. As kinetic energy is more and the total energy is constant, pressure energy outside is less, pressure energy inside is more. Same application, just like this. So you can see there is more pressure acting in the head in the upward direction when compared with pressure acting from top to bottom. So it's obvious that there's a lot of pressure acting, bigger amount of pressure energy acting inside the hut that's acting directly on the top of that hut that makes the top of the hut weak over the time. That's why in the say cyclone times, you won't see the entire hut flying in the air, rather the top of the hut is flying in the air. Why? Because there's more pressure energy acting from inside, which is a real application of Bernoulli's theorem. So these are the simple applications of Bernoulli's theorem, which tells you that the total energy of a system always remains constant, nothing but a conservation of energy. That's it. Thank you for watching.